Well, all right. Looks like we've made our start time. Thank you, everyone, for joining us. So, really great session today on a very commonly misunderstood topic. So, we're really excited to demystify this for you guys today. We will be addressing the many questions that you have submitted at the end, but definitely send us the questions as we go in the questions and answers, and we'll do our best, myself and Richard, while Bob is doing the explaining. And we're going to send you a survey after this, so let us know how we did. And without further ado, Bob, please take it away.
Hey, hi, how you doing, everyone? Glad to have you with us today. My name is Bob Lee, and I'm joined today with my colleague Richard Stockton, and hosting is Adam Brass, and we're all from RF Venue, a company that makes accessories and tools for making wireless audio work better and more reliably. The company is based in Massachusetts, close to Boston. I'm located in Connecticut, and Richard is in Arizona. So we've got a lot of ground covered. Let's talk about the learning objectives today. We're going to be talking about distros and combiners, like the ins and outs. Literally, they have ins and outs. Bunch on one side, few on the other side. Now, we're going to first talk about how they differ. We're not going to spend a lot of time on that, but just some basic things about how a distro is different from a combiner. Sometimes people confuse them, and it can kind of complicate tech support when we think we're talking about one type of device and actually the customer or end user has a different type of device or different type of system than we think that they're describing to us. We'll talk about also RF distribution for wireless mic receivers. That's where distros come in. What they do, um, how what you do if you need more, how you expand the capacity, and also RF combining. This is where the combiners come in. These are for in-ear monitors, what they do, and what you do to increase channel capacity. Okay, let's see. Okay, here we go. There is supposed to be a thing that flies in here. No, okay, I guess it's not doing it. Well, anyway, the general rule of thumb okay, here it comes. Distros and combiners is that a distro that's short for distribution. So it supplies RF channels from a diversity antenna pair, just two antennas, into multiple wireless mic receivers. Okay, so distros handle really low signal levels picked up by receiving antennas. Now, combiners, those are taking um, in-ear monitor transmitters, which are relatively high power, which is 30 to 50 milliwatts typically per input. And really, that's not really high power, but compared to what distros handle, it's a significant signal level. Okay, so that's really the difference between distro. Think of them in terms of signal flow. The distro takes signals and then distributes them out, feeds multiple receivers. Combiner takes signals from a bunch of transmitters and sends them, joins them together to send to a single transmitting antenna. So, in short, distros are for wireless mics, combiners are for in-ear monitors. Okay, so is think about what are your own types of misunderstandings or confusions about distros and combiners. If you have any questions, you can type them into the Q&A uh, box here in the Zoom presentation, um, and we'll get around to answering them as many of them as we can. Richard will try to answer them live, like and type them out. We'll also maybe have some that we talk about, on online. We also have some prearranged questions that were submitted in the registration process. So we've picked some, fairly representative questions to answer later on in the presentation. So getting on now to distros and combiners. These are two of the most recent, the two most recent additions to our distros and combiner lineups. There's the Distro 5 HDR here on the left. Here's the front, here's the back. The combined 6 HDR, which is here's the front, here's the back. So we have a distro and a combiner. They're half rack space. You can put 5 racks of distro, 5 channels of distro, and 6 channels of combined in one rack space. And that really covers 90% of bands out there. So this is something good to know about. These are the HDR designation, and the model name we'll get into a little bit later, but it stands for high dynamic range. So let's look at the 3 distro models that we offer. The Distro 5 HDR, of course, the new one. Distro 9 HDR came out a few years ago. That's a 9-way distro, and the Distro 4, which is the oldest of the models, that's a 4-way distro, but it has a cascade output that really is fully featured like the other 4. So really, you could actually think of it as a 5-way distro. So I mentioned cascade. We'll get into that a little bit later, what cascade means. Okay, so the HDR designation, that, as I mentioned, that stands for high dynamic range. Now that helps minimize the risk of intermodulation, which can really hamper our wireless mic reception. And we'll get into how that works a little bit later. So why use a distro? It's so that you don't have to do this. This is a mess. I think a lot of us have seen maybe smaller versions of this, maybe 5 or 6 receivers stacked up in a nightclub or a restaurant or something like that, and just the whip antennas out of the box stuck onto the back of the receivers, and they're all tangled together. They're interfering with each other. This is a hot mess. Okay, so you want a single diversity pair of antennas to pick up the most basic area. You can use multiple diversity pairs if you're picking up, if you need to pick up different zones. But for today, we're going to keep things separate, simple. And for a room like this, you could cover that easily with just one pair of a diversity pair of antennas. So then you use appropriate distribution to feed that diversity feed into all of the diversity receivers. Now, I've kind of gotten into the habit of talking about mentioning channels, for each diversity feed from a distro. But, really, in recent, in the past year or two, it seems like a lot of people are increasingly using dual and quad receivers. So like a quad receiver, you have 4 wireless mic channels in one receiver unit. They're like 4 separate receivers in one chassis, and they have an A and B antenna input. So really, if I lapse into talking about channels instead of receivers, forgive me. It's a hard habit to break. Mm-hmm. So a little closer look at this mess. That is a mess. Look at all these antennas. They're just stacked on top of each other. Now, the problem with antennas like this is that they pick up signals, but they also, the very signals that they pick up, they also re-radiate a little bit of that signal as well. And that goes into nearby antennas. And so you just get this churning RF cloud of RF noise around these antennas. And they also interfere with each other's pickup patterns. So these are ostensibly omnidirectional antennas, but when you start sticking other pieces of metal, for example, other antennas, in front of these antennas, it alters the pickup pattern. And so in this case, this room is going to have hot spots and cold spots throughout it. And it's going to be different for each of these mics. Now, these mics present another issue that's really not related to distros, but when you put a whole bunch of transmitters right next to each other, um, you get leakage from, RF leakage from one transmitter into another, and that causes really weird modulation problems. You get a really massive spread of RF noise. So if you ever have to lay out transmitters next to each other like this, or even on a smaller scale, get some aluminum bread pans, like the disposable foil kind, and put one in each tray. And that will help shield the RF from one from getting into the next one. That's not related to distros, but it's a little user tip for you. So, um, also, um, let's get into how a distro works. This is sort of a simple schematic of how a distro works. So you take a diversity antenna pair, and we call it A and B. You can call it anything else you want. And each one has a distribution amp that splits up that signal and feeds it into the out to the receivers, almost at channels, but I caught myself. So now, some people think that A is like the priority and B is just like the backup, but they're actually equal to each other. Doesn't matter which one you think is A, which one is B. You can call it 1 and 2. You can call it blue and red if you want to, but they're just two separate, equal distribution amps that take RF in and feed it out to the receivers. Now, I hope everyone knows the concept behind diversity reception is that you have two antennas. They might be spatially together. They might be um, polarization diversity. Well, anyway, you have two antennas, and as long as at least one of them is picking up a good signal, you're going to have good audio. So it's much more reliable than just non-diversity where you only have one antenna, because if somehow the multipath conditions or the polarization of the signal is not optimal for that one antenna, then you get a dropout. But for diversity reception, you have to have both of them in a bad situation for there to be a loss of audio or a burst of noise or something like that. So this is the concept behind the distro in a diversity reception system. So let's put in the receivers. Now, in this case, we have a 5-way distro, and we can feed the A and B antenna inputs of up to 5 receivers. Okay. So, oh no, I need more outputs. The cool thing about distros is that you can cascade them. So with cascading, you are taking outputs of the primary distro, and that's what we're calling the first one. It's, primary doesn't mean it's better than the others. It's just the first one that the RF from the antennas hits. This is the primary distro here, and so we'll call this one a secondary distro because it's taking its RF feeds from that first distro. Now, we can feed this into another distro, and in this case, it's another 5-way distro. So we're sacrificing one pair of outputs from that primary distro and going into a secondary distro to fan that out into 5 more outputs. And this way we get 9 diversity receiver feeds from 2 distros. Now, we can use more distros on the outputs and, employ more secondary distros to get more outputs if we need. Now, we have you can go crazy with them. In this case, on the right, we have a distro 5 feeding 5 more distro 5s for a total of 25 diversity receiver feeds. On, well, that was on the left, I should say. On the right, we have a distro 9, a 9-way distro, feeding 9 more distro 9s for a total of 81 receiver feeds. That's a pretty big show. Now imagine if you had multi-channel receivers too, like dual receivers or quad receivers. You could really go crazy with this sort of arrangement. But you have that flexibility. And also, I want to emphasize that even though these diagrams show, you know, like the same models, like a distro 5 feeding distro 5s or distro 9 feeding distro 9s, you can mix and match all you need. You can put a distro 5 into a bunch of distro 9s, say up to 5 distro 9s, and then you have 45 receiver feeds. You can put a distro 5 into a few distro 9s and a couple distro 5s for a fewer number. You can put distro 9 into whatever you need to do to get the number of receiver feeds for the system that you're doing. Now, I'll say one caveat is that we recommend don't go beyond one level of cascading. Okay, so you can put into your antennas into the primary distro, then come out and go into a bunch of secondary distros if you need, but try to keep it to one level of cascading. You don't want to necessarily go from a secondary distro into yet another distro. That would be cascading 2 levels. Sometimes you have to do that, but you should try to arrange your distro system so that you can get everything done with just one level of cascading. Richard, do you want to add anything?
Yeah, the message here is with all the different distros you can get, you definitely want to maximize your system for the number of channels you need, but then also leave room for growth. So when you're buying a primary and secondary distro or keeping that in mind, try to leave some output ports open for more receivers and definitely a spectrum analyzer such as our spectrum recorder and our RF Explorer, where you can take a direct output of your antenna rig to analyze. It's good to be able to analyze the antenna rig separately before you're analyzing what the receiver is even doing. So just keep in mind, if you keep it to 2 levels, primary and secondary, you're good to go with gain throughout the whole system.
Yeah. Thanks, Richard.
Yeah.
Now, I want to also mention that with these distro outputs, you'll notice that we've labeled them like 1A, 1B, 2A, 2B, and so on. And you don't necessarily have to put like 1A into a receiver and 1B into the same receiver, because all of these outputs are independent and they're equal to each other. But it's a good idea to keep them organized that way from just an organizational standpoint, which will make it easier to troubleshoot. So if you know you have 1A and 1B going to your first receiver, 2A and 2B going to your second receiver, and so on, if you get any trouble, it's going to make it a lot easier to troubleshoot and find out what's going wrong. But there just isn't any functional or any technical reason for doing that. It's just strictly a matter of organizing your system well. So let's now go into some performance tips for distros. 1, use high quality 50 ohm coax cable. We recommend double shielded cable. Now, what we sell at our venue and what we recommend for most uses is RG8X. That's a double shielded coax cable. Now, the the idea behind double shielding is that that outer conductor needs to fully encircle the inner conductor, and that's how it prevents interference from both being emitted by the cable and from getting into the cable. Okay, so you need that complete encircling. Now, foil does a very good job of encircling that inner conductor, but foil has relatively high resistance. Another type of shield is braid, copper braid. Now, copper braid has very low resistance, but it has gaps in it, especially if you bend it. So, having double shielded cable that has both foil and braid, that you get the best of both worlds that way. One makes up for the deficiencies of the other, so you get really optimal shielding that way by using double shielded cable. Now, for long antenna runs, or for like long antenna cable runs, like directly from the antenna to the distro, if you're going more than 150 feet, you really need to start thinking about maybe lower loss types of cable, like RG213, or for even lower loss, LMR 400. LMR 400, you're approaching kind of like almost like a small garden hose, so it's a little stiffer and harder to work. There's another type called EcoFlex 10. Here, I'll write that down for you. Where is it? No, there we go. I just learned about this little tool in Zoom just recently, so I was like, look at that, EcoFlex 10. That's a kind of small cable, about the size of RG8X, but it's got loss characteristics that are even just slightly better than LMR 400, and so frankly, you pay for that convenience. It's not like cheaper. It's a little bit more expensive, but sometimes it'll get you out of a bind and it'll be easier to work with. Okay, so look at that. There it all goes. Okay, so next tip: keep your interconnects between the distro and the receiver inputs short. Like a foot, maybe 2 feet, but you don't want to have if you have like a 25-foot long piece of coax cable, you don't want to use that and just have it coiled up and outside the rack and just go back into the rack. That is not a good way to do it. Just get short jumpers, buy them or make them, whatever, a foot, 2 feet, whatever it takes to get from the distro to the receiver inputs. 1 or 2 feet will really take care of almost every situation that you'll need in your receiver rack. And don't overdrive the distro, because that's what causes intermod. Intermodulation is a bad thing that happens when we have multiple RF signals, and it only happens in circuitry that's nonlinear. So, contrary to popular myth, it doesn't happen in the air, doesn't happen in antennas, it doesn't happen in passive circuits or in antennas or coax cable or something like that. It only happens in a circuit that's somehow nonlinear. Now, that's typically an active circuit, like in a distro or the front end of a receiver, maybe, that's overdriven into nonlinearity. So when you have nonlinearity, those multiple RF signals don't coexist anymore, coexist peacefully anymore. They intermodulate and produce intermod products that can conflict with the frequencies that we're trying to receive. So uh, we recommend don't use active antennas or inline amps unless you absolutely know that you have to. Sometimes sometimes I talk to people who just think more amplification is better, so they amplify the snot out of the RF signals, and then they create more problems than they've solved. So be very judicious about any active circuitry that's upstream from the distros.
Yeah, Bob, I'll touch on that
Yeah.
too. The only time I've ever used an amp is when I knew my cable run was longer than expected. And with cable runs for integration versus live, most likely for live you won't need an amp because you're not going to be really far out with a cable run anyway. An install is different, and if you calculate the the signal loss per your cable that you have, you may decide to use an amp just because you had to go maybe 50 more feet than you thought you did. But if you use the right cable, and we can go over the cable types that work with different lengths too offline. Just don't fall into the just get an amp for everything trap.
Yeah. Okay, the next tip is keep unwanted RF energy out. So typically, because we're using the UHF broadcast spectrum that we're sharing with UHF TV stations, we're adjacent to a lot of the noise that's produced by video walls. Like in the 400 to 450 megahertz, some of that spills up into the 470 to 608 spectrum that we're using. We'll also have to deal with 5G phones, like my T-Mobile phone here. That's a culprit there. I can often see it on my spectrum analyzer. It's like, oh, look at that, around 620 megahertz. There's all this noise going on, and that's from my phone. So even though that's outside of our band that we're using, it can intermodulate with other signals and produce noise that's in our um, area of the RF spectrum. Now, mobile phones are ubiquitous. Everybody's got them. If you're working with an audience, you can figure you've got hundreds or thousands or something of mobile phones in the audience, and people aren't turning them off for a show. So you have to learn to contend with that. And so we recommend using bandpass filtering on any wireless mic receiving system. Nobody ever regrets bandpass filtering their wireless mic system. We RF Venue offers a variety of different bandpass filters. There's a 470 to 608 megahertz one that handles the entire UHF spectrum for North America. But we also have some narrower ones which come in handy for filtering out TV channels, because if you can filter out TV channels as well, that's less unwanted signal getting into your distros and the rest of the system that could possibly cause intermod. Okay, and then we also recommend don't cascade more than one level. I mentioned that before. So please plan your distro so that you only need to go one level of cascading, if at all. So you wouldn't want to, if you have, say, a couple, let's say you have 3 distros, you wouldn't want to have a primary distro and then go into a secondary distro and then come out of that secondary distro and feed that third one. That would be the wrong way to do it. You would take that third one and move it up into the same layer as that secondary distro and just feed them both off of the outputs of the primary distro. Okay, so there are times when you might have to go more than one level for like a really big production, but your goal should be to not cascade more than one level. And also be aware that RFNU distros offer 12-volt DC outputs for powering receivers. So that it's just a sort of a housekeeping tip, because it can keep the back of your receiving rack neater if you just power everything off of the distro. Now, it doesn't power through the coax cable, but it does, we do have 12 volt DC ports on the distros so that you can plug them into the receivers and power everything from the distro. Now, there's a convenience factor there because then you can turn all your receivers on and off using the power switch on the distro. So getting back to high dynamic range. Now, I mentioned that, where's my laser pointer? Here we go. Now, I mentioned that uh, when you have high dynamic range, linear circuitry or passive circuitry, or also what happens just in free space, uh, signals coexist cleanly with each other. In this case, we have 9 signals of varying level, and here's the composite waveform of all those 9 signals. Now, what happens if we overdrive some active circuitry? It's really just like very similar to clipping with audio. If we overdrive an audio circuit, then we get clipping and we get all kinds of bad distortion. Now, with RF, we get intermod because these signals are not coexisting cleanly anymore. They're intermodulating with each other, and they're not producing harmonics. They're producing products that are sums and differences of all the different combinations of frequencies, and so they produce this really ugly cloud of of distortion products that can compete with or overwhelm the very signals that we're trying to receive. So that's why we really have this emphasis on high dynamic range in a distro system, and we'll also talk about it in combining systems for in-ear monitors. So avoiding intermodulation is really a key thing to having a reliable and high performing wireless mic system.
Hey, Bob, I want to touch on that. I know we're going to talk about combiners,
Yeah,
but just keep in
yeah,
mind as you're listening to Bob talk through the intermod uh, concept, it is different than it's not harmonics, it's intermod products because it has to deal with one or more carriers conflicting with each other.
yeah,
So harmonics are created by non-linearity with one frequency, but we're focusing on people who are going to use more than one frequency anyway. So that's why you have to pay attention to the intermods as well. It's basically we're trying to avoid noise in all areas here, and the intermods are the most uh, out of control. Will kill your system instantly.
yeah. This is why you need to use a good frequency coordination program like RF Venue offers wireless system builder, and that's good for up to I think 25 RF carriers. That's for both mics and in-ear monitors. But there's also Soundbase, which last year Sennheiser bought, and you might think that a big major player in wireless is going to tilt sound base toward their products. But no, they've done a really good job of keeping it really brand agnostic. And so they accommodate a lot of different wireless manufacturers and models. And they've really done a good job of not pushing things toward their products. Soundbase is really versatile, and if you get a pro subscription to Soundbase, you have access to RF scan data from all over the world, and so that comes in useful for when you're plotting out a frequency plan. Now, these frequency coordination services, one I should have mentioned also is Wireless Workbench from Shure. These will do the calculations. It's just simple addition and subtraction uh, to figure out frequencies that will work well with each other so that intermod products are not likely to conflict with any carriers that you're trying to use. Now, where was I going? Okay, the the they will figure things out. Now, as I mentioned, it's just simple arithmetic, addition and subtraction, but there are so many different possible combinations, and it grows exponentially the more channels you add. There's a lot of arithmetic there, so let a computer do it. Don't try to do it yourself. Just let the program handle that, and it will come up with frequencies that will work for you. Okay? So if you want to know more about distros and stuff, there's a blog that I wrote a few months ago called Panic at the Distro. It's available on the RF Venue website. And you can use this QR code to access it directly. Now, we also have a whole bunch of other blogs and videos, webinars, and other educational resources available on our website. So feel free to avail yourself of those. They're available free of charge. You don't have to be a customer. You don't have to register or anything to access these. Just go in and learn whatever you want. And you can always contact us about anything that's not clear to you or needs further explanation. We're here to help you understand and make your wireless audio system work better. Let's move on now to combiners. So you have the Combine 6 HDR. That came out last year at Infocom alongside the Distro 5 HDR. So those are both half rack space units. They come with a short rack here and a long rack here, along with a combining plate. That way you can put one in a single rack space, or you can put two in a single rack space. And there you have it. You know, you can have 5 channels of, or 5 receiver feeds of distro and 6 channels of IEM combining in one rack space. Now we also have the older models, the Combine 4 and the Combine 8. Okay. So why use a combiner? And so that you don't have to do this. This also is a mess. All these antennas close to each other and kind of some aiming at the backs of others is not a good situation. For in-ear monitors, you just want to use one antenna, one suitable antenna, combine all of your in-ear monitor signals into it. Okay? And these, when you have multiple antennas together, just like with receiving antennas, they interfere with each other, they create noise around each other, and it's not a good situation. So let's look schematically at a combiner. So just like the distro is a distribution amp where you take one signal and split it out into a bunch of different feeds, the combiner is going in the opposite direction. It's summing several signals together and producing one composite output. Kind of like, think of like an audio mixer, except you don't have like input trims and EQ and stuff like that. It's just straight RF into the summing amp. So we're taking up to, in this case, we're taking up to 6 transmitters and combining them into the single transmitting antenna, and that's the optimal way to do things. It's just combine everything down to one transmitting antenna and have it, something suitable for the deployment that you're doing. Have it cover the stage well, and that's the ideal way to do it. Now, I need more inputs. What do? The cool thing about combiners is that you can combine the output, composite outputs passively. So in RF Venue, we offer a 2x1 passive combiner. And what that does, takes the composite RF outputs from the 2 combiners and joins them together to feed the transmitting antenna. The passive combiner is a transformer-based device, and the transformer is wound so that the signal coming in on either input port doesn't show up at the other input port. They're isolated from each other, but the signal does get to the transmitting antenna. So that way it combines these two inputs to go out to the transmitting antenna.
Can I add something, Bob?
Yeah.
Okay, so when we show you this 2-to-1 passive combine, it works well with lower levels. So 10 milliwatts coming into each port on the combiner, or 50 max, because the isolation is good. But if you're going above 100 or above 50, that's where you have to get into more isolation is needed, and that becomes costly. There's ways to do it, but most of the time people don't go more than 50 anymore. It seems to be common. And just remember, if you're going in at 50 milliwatts on a 6 input combiner, the output is described as a composite out because it sums them all together. So it's 300 milliwatts coming out of that active port. And that's what active combining does. And that's why when you try to combine two together, you have to be careful with that. And again, the connection from your transmitter to the combiner to your antenna, there's no over-the-air information, so it is very much a different power situation. So just remember, if you get to a decision where you have to combine two outputs, you're never gonna cascade, because you can't go active out of active into an active. You combine them passively, just like this diagram shows you.
Mm-hmm. Thanks, Rich.
Mm.
So getting onto that passive combining thing, now if you're using the combined 6 HDRs to, you don't actually need to buy a separate passive combiner because they're built right onto the devices themselves. Okay, it's a little feature added on. This allows you to combine a couple combiners this way, combining combiners. Now the link inputs are the passive combiner on the inside the combined 6 HDR, and the link output is that output port from the combiner. So let's say we take 6 in-ear monitor transmitters and put them into this combined 6, and then we put another 6 into this other one. We come out of the antenna outputs, go into the link inputs, and then that joins 6 plus 6, we get 12 in-ear monitor channels, and that feeds to the antenna. In this case, it's a CP stage antenna, which is really a really ideal antenna for this sort of purpose, because it's circularly polarized. You can mount it on a mic stand, put it on the edge of the stage or whatever. That's why we call it a CP stage. It's also IP rated for outdoor use, so it's really versatile in that way. But understanding that you don't have to use multiple antennas for multiple in-ear monitor systems. In fact, it's better to not use multiple antennas and just combine everything down to a single antenna. So let's go on to performance tips. Okay, they're not appearing one at a time, but we'll work with that. Okay, again, use high quality 50 ohm coax cable. Just like we said before, RG8X, really great. For if you have to run longer lengths, there are lower loss cables as well, but it's not quite as critical for the transmitting side as it is for the receiving side. Keep your interconnects between the combiners and the transmitter outputs short. So like I said, 1 or 2 feet, that should take care of every situation just about. Don't overdrive the combiner. Okay, so lower transmitter power usually works better. So if you have a choice of, like, say 10 milliwatts and 50 milliwatts, you'll often get better performance by using 10 milliwatts. Now that probably seems counterintuitive, but you can actually you'll have better better intermod performance at a lower power level. But you can also more than make up for that reduced power by using an antenna that has gain. So the CP stage has a fair amount of gain, It means gain in an antenna just means that it's not amplification like with active circuitry. It means it's like a focus. It's kind of like a reflector around the bulb of a flashlight or a headlight or something like that. It's focusing the RF energy in a certain direction, and the more tightly focused that RF energy is, the higher the gain is, because it's like having more power, except it's focused in a certain direction. So the CP beam is an example of an antenna that's circularly polarized, and it has really good gain. So you can get out a really long distance with the CP beam. CP stage has a broader pattern, so you don't get quite as much range, but you get a wider coverage. So that's something to keep in mind. Is that you don't have to worry about 10 milliwatts being too little. There are some transmitters also like the PSM 300 from Shure. That's 30 milliwatts. It's fixed. That's a good power level to use with a combiner. Some combiner or some transmitters put out like 100 milliwatts, and that's really way too much for going into a combiner. You would have to step it down, or maybe even use an attenuator or something like that to make it usable with combiners. Next, don't cascade combiners. Like Rich said, don't go from the output of a combiner into the input of another combiner. That's going to really overdrive that input of the second combiner. Just use passive combiners that have a sufficient power handling rating. The Combine 4 and Combine 8 offer 12-volt DC outputs for powering transmitters. Now, thing to keep in mind, though, is a lot of newer IEM transmitter models actually run on 15 volts instead of 12. So we get that a lot where people are trying to power a bunch of PSM 900s or PSM 1000s from the combiners, and they're only getting 12 volts, and they actually would run better, more happily on 15 volts. So that's something to keep in mind when you're using a combiner with some of the newer IEM transmitters. Now we have a product called the OctoPower, which is a little power brick, kind of like you get with a laptop computer, except has a pair of Anderson power pole outputs, and it comes with the Octopus cable. Now, the Octopus cable is one of our products that has a pair of Anderson power poles, and then it fans out into 8 power plugs for receivers or transmitters. Now the OctoPower, it's rated for 12 volts, but it actually puts out 13.8 volts. Because if you know anything about like automotive electronics and things like that, a lot of electronic devices that are designed to run on 12 volts actually will run on 13.8 to 14 volts, which is what you get in a car when the engine is running. And also this this voltage is close enough to 15 volt so that 15 volt transmitters will almost always be able to run perfectly well on that close to 14 volts. So it's a good compromise between the two, and that means you don't have to use a separate power supply for each transmitter. The last tip here is use a circularly polarized antenna. Now, if you've gotten any of our other trainings on like our RF boot camp, or if you've seen some of our webinars on antennas, you know that circularly polarized antennas are really wonderful things. They're really great for in-ear monitors because they transmit a signal that's present in all angles of polarization simultaneously, so that regardless of how the in-ear monitor receiver antenna is oriented, it'll pick up the signal really well.
Hey,
Okay.
I'll add to that.
Yeah.
Remember, if you're trying to decide what to start with, well, honestly, a CP antenna should be part of your toolbox, in your toolbox.
Mm.
What it really shines with is big rooms, and especially outside. The beauty of our CP stage is that it's a CP antenna plus it's weather resistant, so it wins in both angles there. Um, you'll get a point where you're deciding whether to use a DFIN or a CP stage, for example, for microphones. Um, so keep that in mind. You can use our CP stages for both mic transmit and receive, and it depends on your gig. But consider having both available at every gig if you can.
That's Richard.
Hmm.
So, so now let's review what we've been talking about. How did we do on this? Okay. So we talked about distros and combiners. What's the difference between them, and how to not get confused, one with the other. You also talked about what distros do and how you can expand uh, channel capacity or receiver capacity. Oh, I should have gotten that. Um, and also how combiners work for in-ear monitors, what they do, and how you expand channel capacity for in-ear monitors. So, how did we do? Here we go. Take our survey. Shoot this with your phone and take our survey, please. Take a minute or so. You don't have to do it like finish it right away, but take some time to take the survey. And in the meantime, we'll go on to questions.
So Bob,
Great.
I don't know if you know, we had a ton of Q&A come in, which is great.
Cool. All right. All right.
And
That's what I
we
like
have,
to hear.
Yeah,
yeah,
we like
and
to hide them from the trainer to surprise them at the end. So
Yeah.
it's
Yeah.
but we're gonna go over the ones that came in also too, some other ones.
Mm-hmm.
Right, Adam?
absolutely. I've got it in front of me if you guys are ready.
Yeah.
Yep.
Also, I did put the survey link in the chat, just in case you don't have your phone handy for a QR
Mm-hmm.
code. All right, so let's get started here. How do you deal with the harmonics?
Harmonics. I'm assuming you're talking about intermod because intermod is what you get when you have nonlinear circuitry and a bunch of, two or more actually, um, RF carriers. So frequency coordination, that's job one whenever you're putting together a multi-channel wireless audio system.
Oops.
We lost Bob.
All
Oh,
right.
we've got Richard.
Yeah. What we're saying is if you're talking specifically in your racks, when you coordinate a certain way, oh, here it comes.
Lose me some?
When I got you
Okay.
now.
Did you? Okay. Yeah, I saw the little spinning wheel there. Okay. Um,
Go ahead,
so
Bob.
so anytime you're design a multi-channel wireless audio system, that means wireless mics or in-ear monitors and or as well as wireless devices like guitar players like to show up with wireless rigs
Hmm.
and not tell anybody about it. That has to be included in the wireless, the frequency coordination. So that's step one, wireless, frequency coordination. Step two, um, use bandpass filters. That'll keep out a lot of unknown stuff that the frequency coordination plan program won't know about. Third, use high dynamic range products like the distro or combiner. And along with that, don't use any amplification that's absolutely unnecessary. So, so that's how you deal with the intermod. So I'll bring my slide back up
Oh,
here so that you
I
can
can.
see our email addresses. Go ahead, Richard.
Oh, thanks. I was gonna say if you what I was when you got off there temporarily, I was talking about specifically in ear racks, and I'll finish that my concept too is when you're dealing with intermod potential over if you're comparing mics with in-ears, the potential for intermods are the highest with analog in-ear monitor systems. So that's everything that's been out there for since the 90s. Digital microphones are more forgiving with intermod issues.
Yeah.
So that means when you build a rack of analog in-ears, your potential can be high if you don't coordinate appropriately. Coordination helps you control the noise caused by intermodulation in your rack, which could lead to getting over to your microphones, for example, or it could just your in your rack performance is all based on how you coordinate, and that means how far you can walk away. Your coordination equals to how far you can walk away from the antenna. So think about that next time you build a rack or you're doing a show. You can use our system builder to coordinate your ears and mics. You can use Workbench or Soundbase too. And if you want to go in deeper, we can always help you with that further with the settings and stuff.
All right, great answers, guys. How do you properly set gain for combiners?
Well,
Go ahead, Rich.
okay, so our combiners uh, output what comes in, but what when you combine all the active inputs together, it is actually higher, but it's going over the air ultimately, so it doesn't apply. But there, most combiners don't have a gain control. It's what goes out is what comes in, but it adds together. Um, there are combiners out there that were 4 times the price that does have amplification built in, but those are not common anymore. So you go ahead, Bob.
Well, really, that's the thing is that most combiners, including ours, excuse me, don't have any like input trims or anything like that, and that's really not something you see on most, you know, um, combiners that mere mortals can afford. So I think some really super high-end ones like I don't know, I can't remember, like maybe Wizicom or something like that. They're super expensive, a lot more expensive than several times more expensive than ours, and they might have some control over individual inputs. But generally, you don't have to really set gain. Just make sure you put in enough power on the inputs, and also, but not too much power. So generally in the 10 to 50 milliwatt range, and be aware that 10 milliwatts often will perform better than 50 milliwatts.
Yeah, in general, it's like you have enough control on your transmitter itself, um, and you don't need to go above that. So the more expensive combiners, yeah. So another example was the TX8 from Radioactive Designs. It would
Yeah.
go up to a quarter watt on each channel, which meant that's why it cost so much. But then nowadays, it's like even in a stadium, you generally don't see people going above 50 if they don't have to.
Mm-hmm.
So
Yeah. Yeah.
Great.
And if you're using devices that are a quarter watt, you're getting into the realm of licensed operation. You have to
Yes.
actually get a license from the FCC, or like in Canada, I can't remember how they license, but that's the realm of licensed operators, and really only a few, typically like film production personnel, bother to get FCC licenses for their wireless mic gear. The rest of us, we have to be happy with 50 milliwatts or less.
Great. I think just audio people are under a false assumption about this when they like using more gain in audio world. It's not the
Yeah.
same relationship with output
Hmm.
power. So
Yeah.
just be aware that more is not necessarily better. All right.
Yeah.
Next question. What are the best practices for antenna optimization and test equipment for verification?
Oh, cool. I love antennas. I'm a ham radio operator and we love antennas. They're like microphones for recording engineers, you know. Antennas, well, that's a whole other world in itself. But we recommend, well, for receiving, you need diversity pair of antennas. Now we have the diversity fin antenna, which is a polarization diversity antenna, because the excuse me, the angle of polarization of the signals hitting the antenna will vary with the transmitter moving around. Now, the problem behind single polarization antennas, like a single paddle or a single whip, is that if the polarization of the signal hitting the antenna just happens to be at or very close to 90 degrees, the reception is going to be a lot less effective than when it's at some other angle. It drops off very sharply. So the idea behind the DFIN is that you have a vertical paddle and you have a horizontal dipole. Now, sometimes people ask me, why didn't you just make the horizontal one also a fin? So you have like this X-shaped antenna, and it's just that there's no physical possible way of achieving that because of the way an LPDA antenna is constructed. There's just no way to make one that's at 90 degrees that will intersect with the other one. So the next best thing was just to have horizontal dipoles. So that's the ideal thing for like a one unit solution for wireless mics. Now, having two CP antennas, like two CP stage or two CP beam antennas, that's super robust, and the CP beams will give you like really long range. So you could pick up clear across a football field very easily with a couple CP beams as your receiving antennas. And for transmitting through in-ear monitor receivers, again, going the circularly polarized route will never be the wrong choice. You want to add to that, Rich?
Well, I was reading something else that came in, and I know Adam's typing, but we during the webinar, people were asking about the Zone, and yes, we can mention it here, but this requires more time too. And it's great that product is getting out there a lot, and people are curious. But in general, I'll tell you guys my part on it. But Bob, you can mention yours. Is the 4-zone is made for combining zones for the microphone side, and it applies to with ours it's 4, or we could do 8 easily. It has built-in attenuation, because what you don't want to do is have a room full of wide open antennas or zones with wide open antennas. So feel free to email us if you want to talk further about if you have a design in mind. But the whole goal is not to overdo things. So we're telling you, don't put up too many antennas if necessary. Space them out right. Put barriers in between if you have multiple coverage areas. There's ways around it. There's ways around in your monitors. If you feel like you need more coverage in there, then try, yes, boosting your level to the max, but make sure your combiner is spec'd to handle that level. So our combiner, the question came in is which one of your combiners handles which levels? Well, it is on the user guide, but if you have any questions, we can guide you through it. What you don't want to do is just get in the habit of just turning things up and throwing things out there, thinking it's going to perform better. There's a balance to everything. Okay, that's my take.
Okay.
All right, great.
All right,
Guys.
Adam, hit us
I
with
think we only
another.
have room for another one here. We're coming to the
Okay.
end. We've passed
All
our
right.
time. We thank you
Yeah.
for all of these awesome questions. And again, feel free to email us directly. Info@rfvenue gets the whole team, or just email Bob and Richard. They like questions. All right, great. So let's go ahead and have the last question here. I think it's a pretty good one. How can I stack combiners without overpowering RF input circuit?
Well, just from the technique that we described, you don't want to you don't want to cascade combiners. You don't take an active output from a combiner and put it into the active input of another combiner, because that's going to be kind of disastrous. So again, you take combiner outputs and join them together using passive combiners. Now, if you have to do more than 2 combiners joined together, there are higher power combiners, but you have to go to like some RF professional type providers like mini circuits or something like that, and you're getting into the realm of like you really should be an RF engineer to understand how to do this, because it's easy to buy the wrong product. So but generally, if you say take 2 combined 8s and join them together, you've got 16 channels of in-ear monitors, and that will take 16 separate in-ear monitor mixes. Now you can have multiple receivers on an RF channel of in-ear monitors if you have two or more performers who can get the same monitor mix. That'll work out well for you if you keep that in mind. So it's kind of unusual to need like a lot of different monitor mixes. That might come up, but usually 16 will handle most performances.
I would say the beauty of 2 combined 8s is 16. The beauty of 2 combined 6s is 12. And the 12 to 16 mark is where most even Torinacs go with. And because you can easily apply receivers to anyone who wants to hear in, to listen in. But it's how much you want to go out, and it's usually you don't see much more than that.
All right, guys, great. We're still getting questions, so we could probably sit here all day and do this, but we've got to save some information for the next webinar.
Yeah.
So please fill out that feedback form I sent you guys. You'll be getting an email on that. And again, just reach out to us directly. I see some people asking Richard for some meetings. Get that going, guys, and we'll definitely love to hear how your conversation goes. So thanks, everyone. Really great session. Please give us topics for another session, and we definitely like your questions, so keep them coming. Thanks, everyone. Thanks, Bob. Thanks, Richard, and we hope you have a great
Thanks, everyone.
day.
We love doing these webinars for you, so keep coming back.
Yes.
Thanks again, guys. Take care.
See ya.